You know what's really weird? All of the planets in the solar system are either white or some shade of blue, but Mars is very obviously red. And it's not just us that think it's weird. Astronomers have been trying to figure out why Mars is red for centuries. I mean, Galileo was looking at Mars through his telescope in the early 1600s, and he noted that it was a different color than the other planets. And he wondered if maybe there was water on Mars. That's because back then people thought that maybe there was life on Mars. And if there was life on Mars, then they reasoned that there had to be water. So Galileo figured that since he was seeing this reddish planet, maybe it was a blood-colored red, meaning that there was life on the planet. Of course, now we know that Mars is full of blood, and that there is no life on the planet. Or maybe there is, but there definitely isn't any big civilizations of Martians. Otherwise, I'm sure they would have contacted us by now. We know that there is frozen carbon dioxide ice at the poles of Mars, but also that the surface of Mars is covered in iron, and iron can rust, like any raw iron would rust. So it was pretty clear from an early point in our scientific thinking that the reason Mars is red is because it is covered in rust. Now, why is it covered in rust? Well, here's where things get a little bit weird. There is actually a couple of different ideas about why the iron on the surface of Mars has turned into rust. The leading theory right now is that the iron used to exist as a mineral called olivine. Olivine is a magnesium iron silicate. It's a common mineral found in many terrestrial planets, including Earth and Mars, and even some meteorites. Olivine is usually green in color. So if the surface of Mars used to be made up of lots of olivine, then maybe that explains the green color we see in some Martian meteorites. And olivine is good at breaking down in the presence of liquid water. So maybe the surface of Mars was once covered in water, which eroded away the leaving behind all of the iron. But there's a problem with that theory. See, Mars has two important missing ingredients to make rust. You need iron and you need liquid water. Well, Mars doesn't have any liquid water on the surface. It's very dry. But it also has another ingredient that we don't expect: oxygen. We know that the atmosphere of Mars is mostly carbon dioxide. If you look at the top of the atmosphere, you'll find mostly carbon dioxide. But as you go lower into the atmosphere, you'll find more and more nitrogen. And then a tiny amount of oxygen, not nearly enough oxygen to cause rust formation. Or is it? It's possible that when Mars was younger, it had a thicker atmosphere. And if it had a thicker atmosphere, then it could have had a liquid water ocean. Some astronomers think that Mars lost its atmosphere over time. This happens to planets. As a planet gets older, it cools down and eventually the atmosphere condenses and falls to the surface as rain. Then the planet loses its atmosphere over billions of years. So maybe Mars started out with a thicker atmosphere and plenty of oxygen to go along with it. Maybe it had oceans, lakes, rivers, rain, but over time it lost its atmosphere and all of that. Liquid water froze into ice at the poles. So let's recap. We think that the surface of Mars used to be made out of olivine, a green mineral that contains iron. Over time, liquid water eroded away the olivine, leaving behind the iron. Now, if Mars had a thicker atmosphere, then it would have had a lot of oxygen around to react with the iron. The iron would have rusted and Mars would be red. But there's a piece of the puzzle that we're missing here. Just because something could explain why Mars is red doesn't mean that it did. It could just be that life on Mars is so advanced that they've painted their planet red. But I think there's a much better explanation. Now, you might remember me talking about a layer of rock on Mars called the This is a layer of rocks that formed very early in the history of Mars. And these rocks are very interesting because they show evidence of liquid water having existed on the planet. And in general, the Noachian rocks are darker in color. In fact, they're black in color. They're called the dark hemisphere. This tells us that the surface of Mars hasn't always been red. At one point it was black. So what happened? Well, let's talk about oxidation states. Iron can exist in two different forms: ferrous iron and ferric iron. Ferrous iron is found in olivine, the mineral that we think Mars used to be covered in. When olivine breaks down, it releases ferrous iron. Ferric iron is what we find in hematite, the mineral that makes up most of the rust we find on Earth. In order for ferrous iron to become ferric iron, it needs to lose an electron. You can think of electrons as being a negative charge, almost like a magnet. Iron will tend to hold on to those electrons pretty tightly, but if it's exposed to certain chemicals, it will give up its electron and become positively charged. It's oxidized. When this happens, it bonds with oxygen to form iron oxide, aka rust. So if Mars used to be covered in olivine, and then that olivine broke down into ferrous iron, and then the iron lost an electron and bonded with oxygen, then we would end up with a rusty, red surface on Mars. So that means that the real question here is whether or not Mars had liquid water on it, but instead what caused the iron on Mars to lose an electron. Because if it lost an electron, then it would have formed rust regardless of whether or not there was oxygen in the atmosphere or not. Scientists have come up with a few different ideas. One is that maybe the iron reacted with organic acids. On Earth, we find these acids in things like vinegar or lemon juice. So maybe on Mars, there were acids in the water that could have caused the iron to oxidize. Another possibility is that maybe it didn't need acids at all. Maybe the water itself acted as an acid? Remember how we said that water on Earth is neutral? Well, that's not entirely true. Water can act as an acid or a base depending on what it's reacting with. And if it's reacting with iron, then it can act as an acid and remove an electron from iron, causing it to oxidize. The last idea is that maybe it wasn't the water at all, but instead it was the atmosphere. We know that the atmosphere of Mars is mostly carbon dioxide. Carbon dioxide tends to absorb energy really well, especially at high altitudes where the air is really thin. And when it absorbs energy, it becomes super excited. Super excited carbon dioxide molecules tend to be really reactive. They can easily strip electrons away from atoms and molecules that they come across. So if Mars had a thicker atmosphere than it does today, and if that atmosphere extended higher up into space than it does today, then maybe the thin upper atmosphere could have stripped electrons from the iron on the surface of Mars, causing the iron to rust. So, how do we figure out which one of these theories is correct? Well, unfortunately, we're going to have to wait until we can get back to Mars and collect samples of the surface. It's hard to do scientific experiments from thousands of miles away, but I have faith that we will get back to Mars soon. And when we do, I hope that we find some answers. But also, I want to know what you think. What do you think caused the surface of Mars to turn red? Let me know down below. Also, thank you to my supporters who made this video possible. And if you want to support the channel, you can go to the website below. Thanks for watching, and I'll see you next time.